space-time, and because it does that, things accelerate towards each other. This is
Where does
why
it? What causes the acceleration?
the uneven distribution of space-time causes this acceleration.
Okay.
Because before there was anything in there, the distribution of space and time is very even. But as soon as you introduce something in there, you change that. And this change in it creates a path for things to actually fall towards each other. Now, I can't do any more than explain it like that for you, because I mean, I could go into some very, very great detail if I want, and we could go through Einstein's 10 tensors in some very great detail, but you know, you'd probably be bored shitless, and so would everybody else. So just to keep it in layman's terms, think about space, position, think about position, and think about time. Okay? Nothing can be in any position without being subjected to time, because time is continuous. It always moves along, whether you move or not. Time still happens for you.
Does anybody else want to say anything?
Listen to the lecture and you might learn something, Kimo.
Nope.
Time
yeah, hold
moves
on.
for you, whether you move or not.
I'm trying to find out if anyone wants to make any point on what you've said or what I've said or what we're about to say.
I was going to stop and ask for questions. Okay.
No, I'd prefer if Professor Phil just continues, because he's doing a stellar job, and yeah, because he's explaining why you can have pressure without a container. So carry on.
It does, right?
Yeah.
I love the explanation. He explains it very well.
Okay, so now that we have so now that we understand that why do things that are introduced to this distribution, which is a nice clean distribution, all the squares are even, if you like, all the spaces between position and time are totally perfect, and then you know what we've done? We've brought along something that's got mass, and as soon as we put it in that field, we create an uneven distribution. It's so uneven that anything else that comes anywhere near it now gets attracted to the other thing. And this is why we, to all intents and purposes, we see things as being attracted to one another. Now, gas is not a kind of special kind of entity. It has mass. It is subject to the same thing and will bend space-time just as well as something else bends space-time. It's just that the Earth does a super duper job of bending space-time because it's so bloody big. Now, anything that comes within the influence of gravitational field of the Earth will want to fall towards it. But you know something? By the time we get right up there, as we get closer to the Earth, more and more of the gas stays with the Earth. And as we get further up, as we get further away, the gravitational pull gets less and less and less. And we know this because it's less by the inverse square law. Now, at certain stages up there isn't enough energy for the gas molecules. It's very, very cold. And there isn't really enough energy for the gas molecules to be able to have enough energy to escape out of this distortion that's there. So because they cannot escape out of the distortion, they just don't have enough energy to do that, they stay with the Earth. Now, occasionally some of them do. Something happens, they get heated up, and then there's a sufficient energy for the gas particles to reach escape velocity. Once it reaches escape velocity, it disappears, so we lose it. But thankfully, we also have things that are happening on Earth that's creating more of it. So which is a really great thing, because we kind of have this balance going where we lose about as much as we gain. So we're not really changing much. This is how we had an atmosphere around Earth. Okay? No need for a container. Okay, you may
Okay.
ask questions.
Yeah, sure. So we've got this space-time causing acceleration. How do we change the effect with this cause? So how do we increase the acceleration, decrease acceleration, and change the direction of the object going in its vector?
Excellent question. How would we change? So how would we change the amount of acceleration? Well, we need to change the amount of mass. So let's have a look at an object like the moon, right? The moon, about a sixth of the size of the mass of Earth. So because it's a sixth of the mass of Earth, it also has a sixth of the gravitational field of Earth. So it doesn't change, it doesn't distort this space-time as much as the Earth does. It does enough, but the Earth does so much that it actually influences the moon. That's why the moon is a satellite. Okay, the moon couldn't be a satellite but for the fact that it's influenced by it's inside the field, the gravitational field of Earth, inside this distortion that the Earth is creating. The moon is actually there, but it has its own as well. That's why there are satellites that are going around the moon right now. Okay, so for instance, Chandrayaan-2, the one that crashed, the lander, it's still going around the moon. It's still a satellite that's going around the moon right now, and it's in the moon's gravitational field. Okay, so if you
you're
want
saying
to
that,
change it, add some mass to it.
yeah, if I want to increase the acceleration, I just add mass, yeah?
Yes, absolutely.
So let's say I take a car, for example, which is accelerating, and I want to increase the acceleration, I just have to add mass to the car.
No, that's a totally different thing. We're talking about we're talking about if you want to have an increased gravitational field. I'm not talking about the energy. If you wanted to increase the acceleration of a car, you'd need to have to apply more energy.
Mm-hmm. So we
Okay,
have an acceleration, right?
so E equals half mv squared. Okay, so you'd need to apply energy in order to get to achieve to get the car to go faster, of course. All right. So no, I'm not talking to accelerate out. I'm not talking about
I'm
that.
not talking about acceleration.
No, but I'm talking about gravity.
Which
It
gives
seems there's going to be a change up of what the actual topic is here. Does anyone else want to add anything to this conversation before it carries on?
Do you want to discuss
Anyone?
Earth, or
Anyone
do you want
at
to
all?
discuss motion?
Well, we are getting to
Well,
the
what's
point
that,
where
Curve? What's that, mate?
Did you
What were you
find
saying, Curve?
your Nintendo 64? Did you find one yet?
No, I'm looking, but I'm looking. Don't worry, I'll find that Cybertruck.
Good luck with that.
Thanks, mate.
Yeah, we get to the point where Chemo desperately wants to change the subject.
Yeah. So Chemo, I whether or not you believe, Chemo, in that the Earth is flat or not, I hope that my explanation has sort of given you a better idea about what the gravitational model that we accept is, right? Rather than the kind of nonsense that you hear from Nathan Oakley and his band of freaks.
And the other thing is, of course, if there was no such thing as gravity, then there couldn't be a pressure gradient as we experience, because inside a container with no gravity, the pressure within that container would be equal in all directions.
Precisely. Yes, precisely. So I hope you appreciate that, Chemo.
Look, if I wanted a religious sermon, obviously I would head to the church, right? But what we're looking for is a cause to your
Chemo, what you got was an explanation.
acceleration.
That was not a sermon. Sermonizing
That
is
is not
what you do.
satisfactory that you give me your religious rhetoric here.
No, that was an explanation.
Was the invocation of anything supernatural in your explanation, Michael?
In my explanation, no.
Yeah.
No.
Did you invoke the supernatural? Did you invoke God? Did you invoke spirituality?
No, you see, science is a religion in the same way that not smoking is a habit.
So it couldn't be a religious sermon, then, could it? So we
Not
can
really.
no, because it doesn't meet the definition of what we would require to be a religious sermon.
Mm.
So I'm sure Chemo just misspoke at that point.
Yeah, I'm pretty sure of that. He must have. He must have.
So, Professor Professor Phil,
Yeah.
have you personally conducted the Cavendish experiment?
Sorry, could you repeat that, please?
Have you personally conducted a Cavendish experiment?
Many times experiments that are not exactly that one, not exactly with the same frames and the same balls and the same tension wire and all of that, but experiments that are similar. In other words, trying to observe two masses come together. Yes, many times.
In other words, as we would say, close enough for government work.
And have any of those experiments ever been conducted in a vacuum?
Yes, experiments like that have been done in vacuums. Others have been in other controlled environments, where we don't have to worry about pressure and wind and all sorts of other things like that.
Friction.
So yeah, there are instances of this being done in all sorts of different environments to try and get and work out what big G is and get more precision for that.
To all intents and purposes, though, Professor Phil, would you expect to see a marked difference whether or not the Cavendish experiment was done in a helium atmosphere, in a vacuum,
No,
in an oxygen atmosphere, a nitrogen atmosphere? There wouldn't be any significant difference.
No.
Into account forces like wind or air conditioning or massive heat differentials, that kind of stuff.
The spheres are massive enough to not make any difference at all. It would be like saying if I went to 3 stories up, say so 30 feet or something like that, or 50 feet up, and then and drop 2 bricks. 2 bricks are quite heavy. Drop them. It would be safe to say that the wind resistance, that the air resistance would be negligible for those bricks, wouldn't it? Even though they square or rectangular.
Although
so
the point,
because they're massive enough, that the resistance of the air would be negligible, so that the 2 bricks would hit the ground at the same time.
But given enough of a fall height, the friction of the air resistance would, or the drag induced by the air resistance the object would reach what's called the terminal velocity.
Eventually, they would reach a terminal velocity, and yes, totally agree with that. I mean, for instance, when a spacecraft comes back to Earth, it heats up to 3,000 degrees.
Whereby the terminal velocity, again, because of other forces like friction, a pointy-ended, more streamlined object would have a higher terminal velocity than a square brick of the same mass. That would be expected.
Yeah. So basically, the more friction that you're going to achieve. So terminal velocity is the maximum velocity that's possible. That's attainable by an object, okay, through the air.
Yeah, I'm not objecting.
It can't go. It reaches the point where it can't go any faster.
I'm not objecting. I'm just trying to clarify stuff for Chemo, because that Chemo will try to come up with some kind of bullshit.
Oh no, I appreciate that. I'm just trying to say what I can just the very definition of it is that it's the maximum that something So in other words, if you fall out of an aircraft or skydive, for instance, or something like that, you will fall very fast. You'll accelerate. You accelerate towards the ground at 9.8 meters per second squared, and if you flatten yourself out, you could prevent that that acceleration. You could slow it down if you like, if you flatten yourself out, because you're going so fast. There's sufficient air resistance to make you float, if you like. Okay, that's why you can skydive and stuff. As soon as you point yourself down, you now reduce the amount of surface area that's as an opposing force, and therefore you'll go faster. So you can dive. If you put your head down towards the ground, then you'll start going fast again. But there'll be a stage where you just can't go any faster, regardless of the acceleration, because of the friction.
Yeah,
and that's called terminal velocity.
Chemo tends to measure things in inches per liter. he loves to just. I will just throw random terms together and prove my point.
Yeah. Anyway, I'm going to go and get a bite to eat, so I'm going to keep listening to you guys if you're going to keep talking. So I'll stay on. But yeah, I hope Chemo just understood that.
Don't bank on it.
Had at least a basic understanding of what I said. Hopefully.
Well, I don't think it could have been put any more concisely and, shall we say, simpler than that.
Then you need to learn how to do so.
Yeah, I tried. Yeah. Okay. Thank you.
Okay. Thank you very much.
Speaking to Nagger said he couldn't do it any more concisely. I thought, well, it's one thing if you give a long explanation of something, but to say that you can't do it more concisely, that indicates a handicap.
Well, I couldn't put what he said any more concisely as an explanation. So my hat's off to him.
I'm just curious as to why it all was said. You're just talking about atmospheric pressure. That's the key point here to get across to Chemo, is that there is atmospheric pressure. And
yes, but that involves gravity, which he denies, and therefore gravity has to be explained to him, or the effect of gravity has to be explained to him.
Well, does he deny gravity, or does he deny the word?
No,
or does he deny the word gravity?
No, he denies the concept of gravity.
Yeah. See, he doesn't deny the effects of gravity. If you call it gravity, he'll deny it because he's trained to do so, is forced to do so. You don't use the word gravity, he'll agree with virtually anything that you say.
Yeah, well, I've tried with words like downity and uppity, but
those are too close still. You just have to describe the effects. You can't give it a label or it'll dodge away from it.
Well, downity and uppity are the two forces involved in buoyancy, according to Chemo.
We observe a consistent acceleration towards the Earth. We just happen to label it gravity. Whatever label you feel comfortable using, have at it. I mean, it's like this pathetic rhetoric of trying to say, well, thanks for telling us about your religion. Give us a sermon. I mean, again, that's just stuff looking to incite or provoke a reaction. It's a very sad argument.
It's almost like he's a troll.
mean, I don't collect stamps. Is that a hobby?
Every positive thing must have its negative opposite.
Hey, Friday. What else is it Friday yet?
Friday morning, mate.
Nice.
11 hours and 36 minutes into Friday.
Rich, how are you, mate? Is this mic any good?
Nah, it's fucking terrible.
Ah, really? I just fucking got it in the mail. Is it buzzing?
Put it this way: if you got that from a male, that male fucked you.
Not after I paid him. I got two.
You know that noise when you have a quarter-inch plugged into an amp and you have the other end unplugged and you touch it with your finger? It's worse than that.
Yeah, it's like worse than white noise, or it's probably almost worse than like feedback.
Your mic is diametrically opposed to the quality of your conversation. It's that fucking bad, mate.
Now, I'm not sure whether you're pulling my leg or not.
Not at all, man. It's terrible.
Because I can feel a bit of a tugging.
Nah, it's bad.
Thank you. You know, all that talk about gravity and all that business that Spurs there, it just reiterated to him the indoctrination. It's not the argument we should be having. Science isn't the answer.
Let's do a sermon. Oh, great power, gravity, hold me to you. Ensure that I do not fly off this
He's probably
spinning,
gone to have a
rotating
shower.
earth.
Yeah, I didn't hear any of that. I just popped in when terminal velocity was mentioned, I guess.
Changing a little
I think he's
frequency
right
in the
about that.
population
The
over
scam
time
is
is an
dying.
observed phenomenon.
So are you saying that there was some sense out of Spurs?
Can we use?
It just gave him a really strong dose of indoctrination.
Yeah. Can we use the term flaccid? He's gone very flaccid. Yeah.
but yeah, because that's funny because flaccid would be more curved than something that's erect. Yeah. Yeah, we gave him a little bit of. We've got a few Hail Marys to get through. He's just going to forget. Yeah. No. So what yeah,
Oh,
for
Chemo
all my
does,
homies.
when you explain something to Chemo, what he does is he slinks off, because he knows that that he's got the explanation he needs. He slinks off, and then he'll come back a couple of days later, or even just a few hours later, and just pretend like he never heard any of it, and just start all over again.
Is this any better? Creepy Aussie voice sampler.
Yeah. So it's not like it's like they have the retention of a goldfish. As soon as they leave the environment, they just completely forget.
Yeah.
Yeah. Yep, they completely reset. Yeah, that's right.
I call it the FERS, which is the Flat Earth Reset Switch.
Yeah, absolutely. Oh, you nailed it. You absolutely nailed it. That's exactly it. I must use that myself in one of my videos. Yes.
I love a good acronym.
Reset.
Oh, Flat Earth Reset Switch. Because it's something they have to consciously do.
Yeah.
So this is conscious cognitive dissonance rather than subconscious cognitive dissonance, and that's the point of having a switch.
Let's we could probably apply some physics to it. You know how we're talking about terminal velocity before? They've amassed, we've indoctrinated them so much that it's sort of overfilled, and that's then caused it all to spill out again. We've just overdone it. So maybe there's something to that. Their brains just get empty again.
I don't think Hema likes it when I use the word invocation.
I wonder if we could line a few of them up and do some experiments using the scientific method.
Well,
on how much they can retain.
Well, I was going to say, if we get flat earthers of different shapes, that will give us different drag forces to examine.
Well, actually, I was thinking about flat earthers. Let's see the correlation between how close their eyes come together, how thick their foreheads are, and see if
that's getting a little eugenics-ish for my liking. If I'm honest, and I don't really want to play into Chemo's favourite camp, which seems to be, anti-gay, anti-Semitic, and the Nazi Party. So I think we'll avoid that one. I mean, for me, I think actually you could do a much more interesting experiment, which is take people up 20,000 feet, drop them, and then we can actually show the different drag coefficients on each of those bodies, because we'll do it in the wind tunnel first.
Yeah.
And then we'll see how hard they hit that land when they actually reach terminal velocity. Because it'll be terminal velocity less drag factor.
Yeah. Actually, we could give them the Trump test. What is it? Man, woman, whatever it was.
No idea. I pay so little attention to Trump; it's untrue.
Okay, so Trump was bragging a few weeks ago, that he was bragging that he managed to pass this cognitive test. This is where you have to point at some things and decide, and so that's an elephant, that's a lion, stuff like that. And then you had to remember 5 words in a row. And Trump was very, very proud of himself that he could remember 5 words in a row. You know, and this particular test is given to people to, you know, to establish if they've got, you know, dementia. You know, so.
Yeah.
But he was quite proud of the fact no one in history could do it. He said he was the only one in history who could get all 5. You know, so yeah, we could give flat earthers something like that. We could throw in a few good words like gravity, satellite. You know, a few
I
good
find
words.
that a bit weird because I mean I can recall more than 5 words. To be or not to be, that is the question. Whether it's nobler in the mind to suffer the slings and arrows of outrageous fortune, or to take arms against a sea of troubles, and by opposing them, end them.
That's amazing. That's totally amazing. Okay. So we could line up a few words and see how many flatties can remember them. You got to admit, it is kind of funny because I mean, if you listen to Ranty's show, which I do, if you listen to Ranty's show, it is seriously funny the stuff they come up with. Sorry, say it again. Oh, that was hilarious. That was, yeah, I saw that. That was somebody mentioned that to me, and then I had to go back and have a look at that. That was hilarious. He the Gleason map on the moon. Yeah. Yeah, that was funny. And he was so excited. You know, oh my God. Oh, it was like they'd struck gold. Seriously, there must be a bunch of wives who are thinking their husbands are total drongos. There must be. Oh, there's got to be. They can't all be like Paige. No chance. My wife thinks Paige is just having us on. Yeah, God knows. Yeah. But you know, there's enough people who want to be in the club and who pay him to, you know, to produce this content. I suppose good luck to it.